Today we're going to look at QuickSort. It's lead code 912. Actually, this lead code question is just our playground. We could easily use this to implement merge sort, bubble sort, or any other sort. So let's look at the example. So let's say that we have this unsorted array and we need to sort it in ascending order, so from smaller number to bigger one. So what we'll do is we will first have pivot. In this example, we'll be implementing the pivot as a first element, but you could easily do it with, I don't know, random element or a mid element inside the unsorted array. And what we'll be doing is that any element that's left from the pivot will be less or equal to pivot, and the elements that are on the right side will be bigger than pivot. So in order to do that, we will have I and j, okay, and we need to move I to point to the number that is bigger than 4, than our pivot, okay. So 4 is equal, so it's not bigger. 2 is not bigger. Okay, 5 is bigger. Okay, and next we move j backwards until we point to the number that is less than pivot, which is already is. And what we do now is just we swap elements. Okay. So now 3 goes here and 5 is here. Okay. And again, we do this like we move I until we get a bigger number than our pivot. Oopsie. So 6 is bigger than pivot, and 5, okay, 5 is, and when we move j, we need to find the value that is smaller than pivot, so 5 is bigger. Let's go backwards, okay. 6 is bigger than pivot, and then I and j pass each other, which means that j is pointing to an element that our pivot should be, right? So now we just need to swap these two numbers, right? So here we have 3, here is 4. Okay, so now 4 is at the correct position, so right, and we need to recursively do the do this for left and right side, right? So you see here that 4 is in the correct position, right? When we sort the array, 4 is at this position, right? When this array we sorted, then here it will be 2, 3, 4, 5, and 6. Okay. Cool. Now the time space complexity for this one is, so time complexity for QuickSort is O and log n, and for space is log n, because we are recursively like doing this sorting. Yeah, so now please pause this video and try to implement the solution yourself. Remember to do this recursively. Okay, let's do it together. Okay, so first thing we need to do is just call the QuickSort function and have nums and first index and last index of the array. So nums length -1, and because we're doing this in place, sorting will be in place, we need to return nums. Okay, so we need to implement this QuickSort function. Let's do that. right? And if low is greater than equal to high, then we just return. We don't recursively call this function anymore. The first thing we need to do is get our pivot. So we will have a helper function. It will be called partition, maybe. Okay. So just passing low and high indexes. Cool. And now we just recursively call on the left and right side. So quick sort here. Right. So now we need to just implement this helper function. It will get our pivot index. So let's just have a pivot value stored inside a variable, which is nums, which is the first element. Okay, let's have an I and j pointers, which start with low and high indexes values. Okay, and while I is less than j, we first need to I needs to point to a number that is bigger than pivot value. While. So we need another while loop, and we need to actually check if I is less than high, right? Because we will be incrementing this. So I is less than equal, we just increment I. And then j, if j is greater than low, and j is greater than pivot, we go backwards. Right. If I and j don't pass each other, we will have swap helper function that will be just basically swapping the two numbers and j. And when we're done, we of course swap the first element, which is pivot value, with the j, which points to the correct position for our pivot. So nums low, nums j, and then nums j, and we return j. We need to return j because here we expect in our pivot, right? Okay, so the last thing we need to do is implement swap function. So we have array and I and j equal to, oops. So this will be, oops, Jesus. Okay, here we're just swapping two numbers. Let's see. Okay, first we're calling our QuickSort function, and because we're doing this in place, we're returning num. This recursively this calls this function here. We have low and high. If low is greater than high, we just return, which is correct. Okay, we do this partitioning all the way. It looks good. Okay, it doesn't look good. Okay, so we have calling it nums here, which is not correct. Cool. Yeah, and the tests pass. Yeah, that's it. This is implementation of QuickSort. I hope this helped. If you didn't understand the concept and the recursive cases, just draw this up with pen and paper, right? Like I did here in this example, right? Yeah. See you. Till next time. Bye.